Hello everyone, Jason here with VC Edge. This video is going to be part 9 of the interface knife build. We're going to be machining some carbon fiber today. We're going to be making the blade body, which is all made out of some unidirectional carbon fiber. I'll have to do it in a few different stages. It'll be a lot like how I did the blade core, except there's a few more steps involved. So I'm going to be machining both sides of this. Then we'll cut out the main part of the blade. We'll bond in the blade core and the other steel parts. Then we'll put it into another fixture and do the final machining on the bevels. And then it's on to a bunch of hand finishing. So let's get started. I wanted to show you the material I'm working with here first. This is unidirectional carbon fiber. You can see the straight lines that go across the edge here, so you can tell it's unidirectional. It has this sheet of just one layer of woven carbon on the outside, so it looks a little different. Normally this would just be flat, but this helps keep it from fraying when you cut out the blanks and things like that. So otherwise you can get a little piece of the unidirectional that will just peel all the way across it and it'll create a defect. This is going to be machined in 2 halves. So internal features, then flip it over to the external ones. And I'm not going to do the bevels on this side. I'm going to leave it mostly flat, and then I'll cut those out and do the bonding process. Here's a shot of the difference between the unidirectional on the bottom and the woven on the top. If you look at the edge, it's really easy to tell which one's which. One more thing before we start. I've switched to the 50 micron filter material here. Before, if you don't remember, I had the 25 micron in here, and this would start to fill up with coolant as I machine the carbon fiber. So we'll see how this works out. Hopefully this will stay flowing longer than the 25 micron did. Also got some slightly stronger and easier to grab magnets that I use to hold it in place. Just to go over some of the tools, these are either diamond coated or PCD tipped. Got a 1/8 inch 4 flute, a 1/16 inch 2 flute, a 1/8 inch ball. Those are all diamond coated. 1/4 inch ball end mill, that's PCD, that's polycrystalline diamond. And then I've got my face mill with these PCD tipped inserts. That's for all the composite. Although you can machine aluminum with these diamond coated tools, it's perfectly fine. A lot of times that's what they're made for. I am usually just using them on composite though. In the back there I've got a couple other tools that are for working the aluminum soft jaw fixtures that I need to make later. Sometimes people ask about why I have the 4th axis over here on this side of the machine. There's really no particular reason, it's just fine there. I have my tool selection set pretty short and to the same length overall, so that the coolant has the best chance to get to them. But even with this reamer, you see it's in one of the Tormach drill chucks, and it's just a regular length chucking reamer, and it's still got a ton of clearance. Over 2.7 inches of clearance. So that's one of the nice things about having the compact micro arc mounted directly to the table means that you can have normal length tools in the tool changer, so it's not a problem. One of the things I have to be really careful about on this setup, because the material is relatively thin and it's kind of wide, it's about 3 inches, I have to be careful that I don't over torque the vise, because that will cause the material to bow up. Carbon fiber is pretty stiff, but it can bend. So in this case I'm going to be using a torque wrench. Set this to a torque that is tight enough but doesn't cause very much deflection at the middle here. I'm going to check it with an indicator and see how much movement there is. This material is basically just held in place. It's not really tightened down at all. So you'll see as I tighten the vise, that is the middle coming up. So I get about 1/1000th of deflection, which that's perfectly acceptable. And that's with my speed handle on this. Just tightening it down as hard as I can with reasonable hand pressure. We'll see what torque level that is. I just want to be consistent is the main thing. Okay, so that's, in this case, happens to be 30 foot-pounds. That way I can get them the same every single time. At least that's the plan. Okay, let's go ahead and machine this. It'll be internal features first, and then we'll flip it over to the external ones. Okay, now as you can see, this stuff machines relatively fast. That whole cycle only took about 7 minutes. And I do have some fraying that's occurring on the edges. It wouldn't do that if I was using a down cutting end mill, but I'm using an up cutting one. So it's leaving a little bit of fraying on the edges, but it's not really a problem. That's gonna kind of get sanded down a little bit. These are the two halves of the blade body that get bonded together and have to be machined out to accept the blade core and a couple other features on the inside. So I'm just going to flip this over and machine the other side now. Had to reduce the torque to 15 foot-pounds for this side because I've thinned down the material a little bit to get it, to make sure the deflection's a reasonable level. I'm hoping that's enough to hold it in place. It doesn't get machined really hard, but there's a chance, you know. If this doesn't work, like if it moves a little bit or something while it's machining, I might have to do a operation 0 where I machine some holes in this that I can use on the fourth axis, like I did with the handles. If I have to do that, it'll be another step, and I don't really want to do it, but we'll see how it goes. Okay, that seems to have worked out all right. My parallels are still tight, so it hasn't moved on me. Looks okay. I've only machined the false edge on the back for that bevel. I don't know if you can see that. So I've machined that roughly, but I haven't machined the main bevel, and I won't be doing that until after I bond everything together. So let's get these out and cut the tabs off, and then we'll see if our other parts that are going to bond in fit. Alright, so I got these cut out, and I can already see a problem. There's a spot right here where the detent track is supposed to sit, and it's not cut out. It's like barely deep enough. So something's wrong with that tool. Either the tip of it broke off or there's a problem with the offset. I'm gonna have to check on that. But so since I can't fit check that part, I can still fit check this because it looks like it cut out properly. And like these little pins are what you would call a registration in like mold making. So that aligns the blade into the pocket, and then the other one, they both set into those same holes, so everything lines up. But this seems to be a little bit too tight. It's not going down all the way. Looks like I need a little more clearance on the front edge where it lines up with this. So I'll need to take a little more material off on the next one that I try. Since I have to redo it anyway, no big deal. I might as well make all those adjustments right now. Otherwise, it's really close. It's just going to take a little bit more. I left all the tabs on here. I haven't done the finishing of the profiles or anything. I'll do that after the bonding's finished. I'm going to take a look at those tools and see what's going on, to see what happened there. Okay, so I figured out what I did wrong. So this is the tool that cuts that little pocket out, and I went and reset the length offset for it, and the number changed quite a bit. So I started looking into it a little more, and the description for this tool was the same as was for this one. So at some point I had this tool programmed. This is a little 20 thou end mill. I had this one programmed as tool 12 at the same time as this one, and I eventually realized that there was a conflict and renamed this one 13, but then I forgot to reset the length on this one. So that's what happened. Simple mistake, but it could have been way worse. Luckily, these are really close in offset. Like it's only off by like 30 thou or something, but that could have caused this to just plunge right into the material and break it pretty badly. So keep that in mind. A little simple mistake like that can cause a big problem. These are expensive. I'm gonna go ahead and check all the offsets on my tools while I'm at it. Okay, let's try this one more time. Here we go. There's the new parts. They machined all right. We did have one casualty. Was this this 1/16 2 flute diamond coated end mill. I think I'm going to need to get some 4 flute ones. These 2 flutes just seem like they're too delicate. That one broke off. But no matter, got it done. And everything looks like it's fitting. It's a little tight. This is wedged in there pretty good, but it does fit. It's all nice and flush. One of the things I probably didn't mention before is the reason I'm leaving this bevel not machined, and I did this one, is so that I have a nice, somewhat structurally sound area where everything will clamp together nice and tight onto the blade. Otherwise, it's just a really thin section that doesn't have, it's difficult to get pressure on that area when it's being bonded together. But as it is now, it'll be nice and easy to get pressure on that edge. After the bonding, we'll set this up into a little fixture to machine that bevel. The bonding process I'm not going to go into in this video. I might do a separate one on it. It's a lengthy process, and there's a lot of preparation and effort that goes into it. Also, I'm not really sure how much of the bonding process I want to show in these videos. So for now, we'll just keep it to the machining. After these parts are all bonded together, we'll come back and I'll show you what it looks like. Then we'll set it up to machine the bevels. Alright, so here we have the blade is all bonded together. Got the detent track and the blade all bonded in. You can see we've got a bunch of resin squeeze out along the edge. That's pretty much expected. And I'm just going to sand that off on the belt sander. Well, I still have these nice flats to work with. And also this center hole I'll need to ream to the final size. And then we'll set it up into a special soft jaw that I need to make that I can use to hold it in the machine to do these primary bevels. And I'm just checking my drill press table for squareness before I do this reaming. And it looks like it's still good to go. It's on the slowest setting. Shouldn't take much. This is basically already to size, but just a little bit more. I'll do both directions just in case. There we go. So there, I've sanded most of the excess resin off. I have to be real careful that I don't sand into the carbon because I'm going to use this surface back here as a locating feature. The rest of this stuff I'll have to get in there with a little diamond burr and just grind that stuff out. It's quite a bit, the resin's quite a bit softer than the carbon, so it's easy to tell when you've reached the edge of it. So we got this sanded. Enough of the resin is off of there to move on to the next step. This isn't to its final finish. I'll still go back and hand sand this to make it nice and smooth. Just got the excess resin off of it. The way that I want to hold this is very similar to the way I did the blade core. I'm going to use a soft jaw to clamp down on the sides of it, and then it'll allow me to machine the bevels, both sides of the bevels at the same time. I'll use a little pin in here to hold the position, and then I'll use another pin where this can set down on, and then clamp down the other jaw, and that'll hold it in place. This will all be clearanced out so that there's enough room to get the tools down in and do the bevels. It doesn't take a whole lot of tool pressure to machine the carbon, so it should be fine just clamping down on this back edge down here and these faces here. So let's go ahead and machine these out and get them ready. One thing about these soft jaws, you can't always count on them being perfectly square. A little bit of a angle to it. So you gotta keep that in mind when you're setting these up. You can see these aluminum chips really pile up fast. The coolant has a hard time, from that tool, makes these really long, stringy chips, and they sort of pile up on each other really easily. So it's kind of hard to get rid of them. Here it is all machined out. I've got a couple of these pivot pins that I just cut down a little bit so that they fit in there. And you can see how this will work. So that slides onto the pin and it can rotate on it. And then it stops against this other one. So that's how the blade will be located. It's not perfect. It'd be better to have probably a little tab with a reamed hole that I could locate that way, but it'd be a lot harder to clean up the resin on the outside with that. We'll see how well this works. I'm just going to put a little retaining compound on these so they stay in place. That's just Loctite 609. This stuff's kind of expensive actually. It's surprising. I'll just let that dry and then we can set this up. Got these mounted in, so we can try this out, see how well this is going to work. So you see how that fits in there. Got our two locators and it's flush against the back. The other jaw comes in and clamps it down, and that'll hold it secure for when the tool comes in. Let me grab that tool, I can show you what it does. This tool is going to be the one doing the work. It's the 2-flute PCD cutter, and because it's long enough to get all the way down to the bottom of the bevels without running into anything. It is going to get into the edges of the fixture, so it will self-clearance, and that's actually fine for this tool to cut aluminum. Diamond tools can cut aluminum just fine. The feeds and speeds are a little bit different, so I will put in a shim in here that will simulate the blade thickness and let this clearance out like I've done before with some of the other jaws. And then we'll put the blade in and it'll be ready for the final machining. One of the things about this fixture that I'm a little bit unsure about is it's only supported from about here over, and on this end it's free, but I believe it's rigid enough for it to still be machined just fine. I'm taking pretty light passes across this and it's going from the top down. But we'll see. If I end up getting a bunch of chatter or something happens to it, we'll have to rethink this. The only other thing I'm worried about is the tool actually hitting the hardened steel blade. I don't want it to touch that at all. We'll see if it ends up touching it. You really don't want diamond cutting tools to touch steel. It's bad for it. Aluminum's fine, steel's bad. Also, these holes here, in case you're wondering, they're just for drainage. They're the same height as the top of the jaw, just to let out some of the coolant and chips. For the 0 point on this, I'm using the side of the fixed jaw and then the top of the jaw, because those are the same surfaces that I touched when I was doing the machining of that jaw in the other position. The only thing that's different is the position of the y-axis, which I'll just be using the middle. Depending on the blade exact thickness, it might vary a little bit. So I'm just going to touch both sides in the y-axis to get the midpoint. Okay, we're all set. That's all clearanced out. My cutting tool is still in perfect shape. You might have noticed that I adjusted the coolant nozzles, and something I don't do very often, but in this case it's necessary because when this is being machined on one side or the other, one of the jets will be completely blocked off when it's doing the other side. So I need to make sure that both jets are hitting the edge of the cutter. Got a nice even stream of coolant on each side, and the middle one is hitting right in the middle. Yeah, you can hear it saying a little bit there at the edge. I don't think it's too much of a problem though. We'll have to take a look at it after it's done. Alright, so let's talk a little bit about how well that worked, or didn't work. The bevels are nice and smooth. I do like how that turned out. It's going to be nice and easy to smooth it out with the hand sanding. The only thing is I did have the tool touch the edge a little bit. It just sort of skimmed it on this side. and this side it did not. Also, there's a little bit more of a lip left over, so possibly my centering was just a little bit off. Instead of zeroing it on the jaws, I might need to just zero on each side of the flats, closer to like the middle of the blade. Maybe there's just a little bit of twisting. Other than that, it seems to have worked out pretty well. Where you could hear the tool making a little bit of a different sound, it was still cutting, but it was deflecting the blade a little bit, and so there's a thicker amount of material left over on these sides. I might need to come up with a way to stabilize the back edge, something that can clamp onto this rough surface on the back and hold it. I'll have to think about that. I'll probably end up just designing in a little tab that sits here with a hole in it that will at the same time locate and also provide some stabilization for the front. There's no delamination or anything, and this can be sanded. The carbon fiber sands relatively quickly, even by hand. So I've got this nice guide of the blade edge here that I can use to sand down to. It's looking good. The main thing is that these plunge lines right here are all shaped in. So I was getting ready to start sanding on this thing, getting my mask all ready for sanding carbon fiber, and I really just hate sanding on dry carbon fiber where all the dust gets everywhere and gets all over you and get itchy. The masks that you need, the N95 ones, I think everybody knows what those are now. They're used in industry most of the time for filtering out dust particles like carbon fiber. They're really hard to get right now, so if I can have a solution where I don't have to wear the mask and it also helps keep the shop clean, all the better. I've always thought it would be really nice if I could just put this under the sink and wet sand it while it was in there, but it's not very practical to go into the kitchen and do that. So I came up with a solution for running water across this while I sand it. It's just a bunch of stuff that I cobbled up from around the shop, and hopefully this will work out pretty well. I think it will, but I'll come up with a more professional solution in the future. It's a good proof of concept though. What I've got is a little magnetic base that I attached a little manifold thing that I had with some fittings and some lock line, and that I can clamp directly to my steel table and then aim it towards the blade. I got the blade on one of these suction vise things that you can articulate around, so that's handy. And then the tubing I've got going down into this bucket that is just full of water, and there is a little tiny submersible pump. This is just like one of the lowest flowing ones that you can get. I happen to have this just hanging out. I bought it for some other project and never used it, so sometimes it's good to be a hoarder. Over the top of the bucket I've just got some of the filter fabric that I use in the CNC machine, just to help capture some of the particles and help keep from the splashing. Yeah, so I'm not going to show much of the sanding process. It's just me sitting here sanding until everything's all nice and smooth. I'll do my future self a favor and just not really film much of this, but I'll show you how it all looks when it's done sanded, and I'll tell you how long it took. There's a lot of advantages to wet sanding versus dry sanding. Obviously the first one is that you don't get all the particulates in the air, and also your sandpaper will last longer. It won't load up where the particles get embedded into the sandpaper and it pretty much stops cutting. And also you can see what you're doing, so there's not all the dust all over your workpiece. So it's just good all around. I don't see any downsides to it at all. I mean, except for the fact that it's wet. I mean, yeah, you might get a little splashed on you, but hey. I'm starting with some 220 grit. I don't want to go down to a 80 or anything like that. I might go to 120, but even that's a little bit aggressive. Contrary to popular belief, hand sanding is more aggressive than machine sanding because you're putting more pressure in a localized area. I'm starting with 220 and then I'll work up to 320, and it's usually where I stop, just to give a nice hand rub satin finish. The harsher grits have a risk of gouging into the carbon. It's relatively soft, so it can leave a deep scratch that will take a lot of sanding to get rid of. Okay, I think that's all I need to say. I'll see you after this is done. So here we are after about an hour and a half of sanding. Got it to a pretty decent finish. This one's kind of interesting. The lines in these are usually a little bit more uniform, but this one's got a few little waves in it. Just an artifact of the composite layup. Usually they look a little more like this. The lines are a little more straight, but you know, they're all going to be a little bit unique. Now, this isn't sharpened yet, so I've still got that to do, but that'll be done after all the fitment check and everything is done. And I also have a little piece here. It's like a little placard. That won't get bonded in until after the anodizing. So, still got some things to do, but this part is ready to go. So I think that's good enough for this video. In the next one, we'll do the fit checking of all the pieces and check the function of the knife. Then we'll do some anodizing and then bond in a little placard here and sharpen the blade. I think that might actually be finished for this thing. Don't forget to subscribe if you haven't, just so you don't miss anything. So with that, time for me to get back to work. I'll see you on the next video.